Welcome to Ask and Learn.
In this case, we are tasked with finding out whether 4 different nuclides are stable or unstable and thus making them radioactive. And if they are unstable, what methods would they undergo in order to become stable and stop being radioactive? The first sample we're given is potassium 45. Now, if I look at the periodic table, you'll notice that potassium has a molar mass of 39.1. So, a molar mass of 45 is far too many neutrons for this to be a stable isotope. So this one is definitely going to be unstable. The question is, what method would it undertake then to become stable? Now, potassium is a relatively light nucleus compared to some others, so it's unlikely to undergo alpha decay. So it's probably going to undergo beta decay, in which case an electron is ejected and consequently it will decay into a proton. So, causing a neutron to decay into a proton through that process. The next one we'll look at is an isotope of iron 56. Now, looking at the periodic table, iron already has a molar mass of 55.8 grams per mole, which is pretty much right on this isotopic mass. So, we're going to consider this particular isotope to be stable, whereas the last one, not so much. Now, moving on to part C, we find an isotope of sodium 20. Now, sodium has a molar mass of 23.0 grams per mole if rounding, and that indicates that this one has too few neutrons to be stable. So we are going to classify this one as unstable. Like the potassium in our previous example, it's too light to undergo alpha decay. So, like before, it is likely to undergo beta decay, but of a different type. Instead of being an electron emission, it's going to be a positron emission, in which case it will cause a proton to decay into a neutron, and unlike before, it's actually going to go down in atomic number. Alternatively, it could also undergo electron capture. So I'll draw up another one here. And in electron capture, it induces a proton to decay into a neutron with the same results. Alright, and that leaves us with part D, in which we're looking at a relatively heavy isotope of thallium-194. Now, thallium has a normal molar mass of 204.4 grams per mole. Now, obviously, being between 10 and 11 neutrons short is not going to do much for the stability of thallium. Now, unlike the other examples we've seen, thallium is a relatively heavy isotope. So, it can in fact undergo alpha decay. Alternatively, heavy things can also undergo positron emission, and finally, it is also possible for it to undergo electron capture, since these two, that is, often go hand in hand, especially since the result will be the same nuclide.